Hey, welcome back. We're going to continue our lesson on what a limit is. If we were to take a look at the function over here to the right, we want to ask ourselves two questions. The first is, what is the value of the function at x equals 0? Now notice we use a big word here, the word at. We mean we're at a place. And that's easy. If we look at the graph at 0, the value of the function is negative 2. Now, please note, we say the f of 0 equals negative 2. We have to be specific about our answer. We're not just going to say negative 2, because what's negative 2? Well, we want to say that the value is negative 2. So we have to be really specific about our answer. So now let's go back and look at our graph again. But this time, we're going to ask the question, what is happening to the values of the function as we approach 0? As we approach 0, now we are on the line itself. We're on the function. So we're not at 0, but we are on the function. We are approaching 0 from the left and the right side. So what we want to see is, as we approach from the left, it looks like we're approaching 4. And if we approach from the right, it also looks like we're approaching 4. And that's what this says. If we look at both sides, the value approaches 4 right there. And that's what we want to see. We want to see, what are we approaching? Even though at 0 we're at negative 2, but we're approaching 4. If we go back to our example of the house, that's like saying our road is approaching where the house should be, but the house would be somewhere else. Right there. So, and notice that the value and the limit don't have to be the same. That the value and the limit do not have to be the same. Now, if they are the same, we're going to say that the function is continuous at that x value. And again, we're going to define continuity at a later time, but we can kind of get the idea of what it means to be continuous, that the value and the limit have to be the same. So how do we write a limit? This is just a quick review of what you did last year in pre-cal. The limit of a function is written as the lim as x approaches a of our function. It is read the limit as x approaches a of f of x. In other words, it says as we approach x, what is happening to the value of the function? So there are two sides to a limit, and you talked about this last year in pre-cal. And this is called taking the left hand and the right hand limits. So we have a graph right here. We have a graph right here. Notice for y equals f of x, at x equals 2, the value does not exist. Now, you might have written undefined, something like that last year, but in calculus, we write does not exist or D and E. That's our favorite phrase that we're going to be learning here. D and E. It does not exist. But that does not mean that the limit does not exist. Recall, the limit only asks what we are approaching on the function. Therefore, we must look at both sides. The first thing we have is what's called the left-hand limit. And that is, if we think about it, x equals 2 here, we have the left of 2, and we have the right side of 2. As we approach from the left, we're saying, well, what are we approaching from the left? We have a right-hand limit as well. And the right-hand limit says, well, as we approach from the right side, what are we approaching? To distinguish between the left and the right, we have these little minus signs and this little plus sign up here. The minus sign means we're talking about the left, and the plus signs mean we're talking about the right. And if you notice, in both cases, the left side and the right side, the y value is approaching 4. And in pre-cal, you probably would have written it this way, as x approaches 2, the y value approaches 4. Now notice they're approaching 4 on both sides. We want this. This is happy. We want this because what this tells us is that the actual limit exists itself. Single-sided limit, be careful, aren't really the limit. The limit itself is, are we approaching from the left and the right? Since both are the same, we would say the limit as x approaches 2 is equal to 4. Like I said, this is called the actual limit. And notice there's no more plus or minus up there. Right. Rules for limits to exist, so this is just a really easy way to remember it. The limit exists only if the left and the right-hand limits are the same. Or mathematically, if the limit from the left equals the limit from the right, then the limit exists. So what we can kind of say is that the left limit equals the, the right limit. So again, this is all just a review of pre-cal. So let's go on and take a look at some examples from a graphical standpoint of a limit. Use the graph below to answer the following question. Now for question number 1, they're saying, what is the value at -3? Well, let's look at the value of the function, and I can look here at -3. It looks like my value is 0. Now, this one says, what are we approaching? So now we are approaching. As we approach, and in this case, from the left. So let's take a look here. As we approach -3 from the left, it looks like we're approaching 0. So I'm going to write down 0 here. Same thing here, but now we're going to approach from the right-hand side. And I can take a look here, approaching. Now notice, I can start way over here, but I'm approaching -3, so I'm going to get close to it. So I'm going to start at this -2. The function, again, is approaching 0. Now notice, these are both the same, and that makes us happy. So now for question 4, they want us to find the actual limit. Well, if the left and the right are the same, the actual, I don't know why I put a 3 there, so that's definitely wrong. If the right and the left are the same, then the actual limit has to be the same as well, 0. So notice here we have the value is 0, the limit is 0. So at 3, would this be considered, at -3, would this be considered continuous? And the answer is yes, and we're going to talk about that later on. So let's see here. Let's try -5. As we approach -5 from the left, so if we take a look here at -5, on the left, oh no, it looks like we're approaching a y value of -1. On the right side, that's what we're doing now, on the right side, as we approach -5, it looks like we're approaching 0. So notice these are not equal. They're not approaching the same. So you kind of want to think of like a limit as like a car crash. You want to think at the left and the right, they're heading towards each other. But here, they're going to miss each other. So because the left side is -1 and the right side is 0, we're saying here that the actual limit at -5 does not exist. And that is because we can say that the limit from the left, as x approaches -5 from the left, does not equal the limit as x approaches -5 from the right. And you should always write that down. What's the value at -5? Well, that's pretty easy to get the value. That's just the solid point, which is -1. So let's talk a little about continuity. Would this function be considered continuous at x equals -5? And the answer is no. 1, the limit does not exist, but the value is -1. So we can say this, oh, the answer is no, and that is because the limit right now does not equal the value. That's all we need to put right now. There is a little bit more to it, but if you just get that for continuity right now, you're doing brilliant, okay? All right, the next one. Well, what about being continuous at -3? Well, we already established at -3, the value was 0. If I can write that down. The value was 0, and the limit as x approaches -3 was 0. We should always write it down this way. So they are the same. So therefore, yes, this would be, whoops, let me write that. Pencil's not working too well. Therefore, we would say, yes, this would be considered continuous. And that is because the limit equals the value. right there. Very easy to do. So try -2. Ready for -2? What is the value at -2? I can look at the graph up here at -2. The value looks to be -2. What's the limit as x approaches -2 of our function? Well, looking up here, on the left, it looks like we're approaching -1. On the right, same thing. Looks like we're approaching -1. So these are not equal, so therefore the answer is no, and that is because the value does not equal the limit. Very easy to do. All right, so take a pause from here, go on to the next video. We'll talk about some more algebraic applications of limits. I'll see you guys then.